Hey guys, I am finally getting back to the HP 8662A I got last year. If you recall, I rebuilt the power supply and replaced a digital analog converter on one of the modules. They got it working almost completely. Two things I want to address now if I can. One is the rotary encoder does not work, so its knob doesn't do anything. And the fan is very noisy. The other issue with this is that when I sweep, the output level is not consistent. It varies a little bit. I can live with that if everything else gets resolved. Now, what got me back to working on this now is, so I didn't know how to get the front of this off. Some of you sent me some tips, which I kind of got, but what really set me over into getting back into this was I scored original service manuals that are just pristine. I don't know if these were ever open, and it includes disassembly instructions and everything. So up until now I've been working off of some PDF scans online, which are fine, but this is so much better because it has these huge fold-out diagrams, schematics, everything. There's no excuse not to get everything working right. In other words, now. So I took the plunge a moment ago to opening up the front. So what you have to do is there's a plastic decorative strip on the top and on the bottom. You have to pry those off. And they're just 2 screws on top, 2 screws on the bottom, nothing on the sides. And then, ideally, you grab either side of this angled control panel and pull straight out. Took me a little bit of finesse, or they even say to grab the RF connector down here. But yeah, that sure enough, it does come out. There are slides. It's designed to slide out, so that there are rails here that slide out about 1.5 inches, and then it tilts down. So that's very cool. I mean, talk about being built for servicing. Fantastic. I thought I was going to disassemble the whole thing and do all kinds of craziness. Anyways, optical encoder is right there. Looks like if I can carefully pull this ribbon cable out, get it out of the way. Now we got a date, July 1984. It's getting kind of crusty, isn't it? So, that's a rotary optical encoder. I imagine it has a metal disc in there with a bunch of slits cut into it, and an optical sensor and a light source. And as it rotates, the light gets chopped up and it detects those pulses. And I believe it uses incandescent light bulbs, of all things. They had LEDs in '84, but maybe they weren't quite up to the task. I don't know. But that's the challenge, it looks like. Yes, it does have a little separate plug of its own, so we can just take that out and figure out how to detach it from the front. Let's see if I get this out. Yeah, it's nothing special there. Maybe there's a set screw on that knob. Of course there is. So yeah. So even assuming I can get it out, it is a matter of what do you replace? Nice little snaps on that too, up here. So what do you fix it? I've heard some guys try with varied success about retrofitting an LED into it, or get some super tiny, they call them grain of wheat or grain of light, grain of wheat or grain of rice, little mini incandescent bulbs, and do some micro soldering. These set screws. First, let's get this knob off, then hopefully there's just a nut I can loosen and pull the thing out. Alright, let's give this a try. More leverage. Oof. Got it. Ooh, that one was not tightened at all. Cool, that's what I was hoping to see. That I can deal with. Just need to find a wrench. Oh, it was easier than I expected it to be. Bulb must be on the other side. Oh, okay. Well, yeah, it's right there. Check that for continuity, I guess. I found a vendor online selling these bulbs. Actually, I found a few places selling these 683 T1 type incandescent bulbs. I got these from a vendor on eBay. They're about $1 each. Mauser has them too for $2 or $3 a piece. Little grain of wheat light bulbs. So, I already got some comments about using LEDs, and yeah, it's a possibility. But these are readily available. I found a really good guide for repairing this, and this is what the guy used, so I figured, why not? They're rated for 25,000 hours of use, so I think we'll be okay there. Plus, I wanted to get something that would definitely fit in there and definitely work, so I'm just going to clip this. Looks like it's held in by friction. There's a little metal sleeve next to the bulb. Let's see if we can get this out. Any drama? Yes. Let's compare it to the new one. Sure looks to be. Let's check continuity on the new one before we put it in. Yep, these are good. Alright, so actually that sleeves are just seems like it comes out pretty easily. So I'm gonna slip this in and then very carefully solder it, same as the old one. Let's see, let's try to bend these leads over. Very fiddly to work with. I'm used to working on much larger stuff with thicker leads. The wire's so fine I can't even get a grip on it. That's better. Alright. Wow, I forgot how loud this thing is. So, does it work? Yeah. It sure seems to. So you do times 10 or divide by 10 to control which digits change. So right now we're on 10th of megahertz. Now we're doing megahertz with the knob. So it's hardly essential to the operation of this device. You can always key in the frequency on the keypad or use the up-down buttons, but I think that's a nice thing to be able to do, especially for output level. So amplitude. Brain's a little fuzzy on how this thing works. There we go. I hear a little read. I don't know if you can hear that, but I can hear the little relays clicking inside when I do that. That's what I really wanted the knob for, so I'm going to vary the output level. Very cool. I wish every fix was that easy.